Yes.
All right. It's 4:45, so let's get started with the session. Thank you for attending today. This is the ABCs of BDCs, Big Data Clusters for Beginners. So if you've heard about big data clusters and are maybe wondering a little bit more about them, this would be a good session for you. This is mostly a demo session. I only actually have a total of 12 slides here today, so we're going to be spending most of our time actually demoing a big data cluster and working with it. And yes, all of my demo materials and the slide deck are available for download, and I have the link for that at the end. So just to very briefly introduce myself, my name is Bob Fusateri. I've been working with SQL Server and the Microsoft Data Platform for about 15 years now in a whole bunch of facets. Probably the best information on this slide you can find is my contact information. So if you have any questions that we're not able to get to at the end of this session, or if you're watching this recording later and would like to reach out and ask a question, please feel free to contact me via email or Twitter, or you can check out my blog. All that information is on this slide, and I will have it again at the very end. So what is a SQL Server Big Data Cluster? Again, this is a relatively new technology that came out in SQL Server 2019. It's starting to get some good press, but I know there's a lot of people who probably still haven't worked with it yet, so that's exactly what I wrote this session for. SQL Server Big Data Clusters are a tool that allow relational data in SQL Server to integrate with Spark and data stored in Hdfs and other big data tools. It relies heavily on enhancements that were made to Polybase in SQL Server 2019. It does a really good job, even better than before, of allowing virtualization of data from other systems. And it also has deep integration with Apache Spark. So you can now access your data through data that is stored in HDFS, either through Apache Spark, or you can connect to it and access it through SQL Server in a couple different ways as well. Now, there are a lot of moving parts to a SQL Server Big Data Cluster. This is a diagram here of everything. SQL Server Big Data Clusters run on Kubernetes, which is a platform that allows for essentially virtualization of a process instead of having a whole virtual machine where we virtualize the entire machine and install an operating system. This allows processes and applications to essentially be virtualized in a layer. And it is divided up into things called pods, and containers live inside pods, and Kubernetes is an orchestration framework that allows control of all this at the pod level. This is a complex topic that we're not really going to discuss today. You can see many other sessions on Kubernetes. I'm guessing there probably has been one already today, if there hasn't already. You can get very in-depth in Kubernetes, but the idea I'm trying to bring forth here is a SQL Server Big Data Cluster has a lot of moving parts, and it is all orchestrated through Kubernetes. And all these different services and nodes are, when you create a big data cluster, they are spun up and all controlled through the Kubernetes framework. Now, the ones we're going to focus on today are the ones inside the green box. We're going to talk mostly about the master instance, the SQL data pool, and the storage pool. These are kind of the biggest parts of a big data cluster that you would be working with, especially for an intro session like this. And that's what all the demos today are going to focus on. First, we have the master instance, and the master instance is a regular instance of SQL Server 2019 in the big data cluster. It's running on Linux, on Kubernetes, but it is still a regular SQL Server instance, and this is actually your main endpoint for connectivity. When you connect to a SQL Server big data cluster, you connect through the master instance, and you can connect to this master instance with SQL Server Management Studio or Azure Data Studio, just like any other SQL Server instance. If you are like restoring databases into a big data cluster, you would also restore them into the master instance. Now, the master instance has a couple other jobs. It handles all the communication with the other areas of the big data cluster. It also stores all the metadata for the big data cluster. And when we connect to one in a few minutes here, we'll see the databases that contain that information. But it has metadata about the big data that's being stored in HDFS. It has metadata about external tables. It has a shard map for the data that is in the data pool. So there's a couple extra things, but for most purposes, this is a normal instance of SQL Server. Next, we have external tables, and most of the data in the big data cluster that is not residing in the master instance that we just talked about is usually exposed as an external table, again through Polybase. And Polybase is not a new technology. It's been around for a couple years now, but it has been made significantly better in SQL Server 2019. So external tables allow us to expose this data that's located somewhere not on the master instance. So whether it's sitting in Hdfs or on another server completely, it could be exposed through an external table. But you can query the data in an external table just like any other table. And there's some great optimizations. This is way better than a linked server. There's good predicate pushdown, so it's not like a linked server where you'd have to pull all the data back and filter it locally, and performance is terrible. This is a lot better than that. External tables are read-only. You can create and select statistics, but you can't modify your data. You can't create indexes on it. You can't insert, update it, or delete it. This is primarily for read. But all the queries here are real-time, taking place on whatever system this data is residing on. And because we're running in Linux, the external tables in a big data cluster only support the data sources that are supported by Polybase on Linux. But that is that the things that are supported in Linux that are not supported in Linux that are in Windows are getting shorter every day. So pretty much everything will work at there in this point, which is awesome. Next, we'll talk briefly about the data pool. Data pool is another area of a big data cluster. This is a set of SQL Server instances that will provide storage and compute, and they are managed by the master instance. So you can take data from the master instance or from a big data location in general and load it into the data pool. This will allow you to essentially shard this data across the multiple servers in the pool. So if you have a data pool with 4 servers and you put a bunch of data in your data pool, that data is now spread across all 4 servers and each has 1/4 of the data. You can get some incredibly high performance here now because if you query the data in the data pool, you have 4 times the resources that are actually going to be scanning through that data and delivering results to you. And we'll see that a little bit later when we actually go to a demo and work with that. But you can offload analytic queries from the master instance. You can stage data. Maybe if you have queries are slower, you can stage the data in the data pool and actually get the query on the data in the data pool, and you get better results that way. And finally, we have the storage pool, which is the HDFS area of the big data cluster, right? So this is a HDFS storage system. It provides persistent storage for your semi-structured and your unstructured data, your CSV files, your Parquet files, etc. And you can access the data that is stored in the storage pool either through the SQL Server master instance with Polybase, or you can also query this data through Apache Spark. So that's a very brief introduction into some of the areas of a big data cluster. Let's talk very briefly about creating a big data cluster. As I said, there's a lot of moving parts in a big data cluster, and creating one is not simple. There's a lot of steps involved. It takes some time. The data cluster I'm going to be working with today, I created in Azure Kubernetes service, and it takes about 10 or 15 minutes to actually go through all the steps and create a big data cluster. So it's not just something you turn on and get right back. It actually has to be built. There's a couple different ways you can create one. My personal favorite way to create them is through Azure Data Studio. There's a great wizard. So if you open Azure Data Studio, click on the ellipsis up here, you can go to New Deployment and you get a deployment menu where you can deploy quite a few different things now. One of your options is a SQL Server Big Data Cluster. If you click that, it will take you through a wizard where it'll ask you some questions about how many nodes do you want, what's your account GUID for Azure, etc. And when you're done with that wizard, it will actually go ahead and produce a notebook. And the notebook contains all the steps in the code necessary to create the big data cluster. You do need a couple client tools installed. You need the Azure CLI, which is an application called AZ Data. This is a Windows application that has to live locally on your machine, which sounds kind of counterintuitive at first. I know people are thinking, oh, I'm creating this in the cloud. I don't need anything locally on my machine. No, actually you do for this. So you need this application called AZ Data, and it will walk you through installing that. There is a plugin that is very helpful for Azure Data Studio, if you go to the extensions, it's called the Data Virtualization extension. This gives you some wizards that will help you with data virtualization. But once you have those, you can actually go and just run through this notebook. It'll prompt you for a password and make you authenticate into Azure, but otherwise it will just go through and create the entire big data cluster for you. Again, for me, it usually takes about 10 or 15 minutes. And when you're done, it will connect you to your big data cluster and you're on your way. So that's a very brief look at creating a big data cluster. Again, you can have an entire session on this. It is not a simple matter, but the notebook and the wizard in Azure Data Studio is a big help. So that's how I recommend creating them. And then finally, let's get to the actual demos here and talk about what we can do with our big data cluster. So again, I've created one already. I'm connected to it here. I named it BDC for big data cluster. And when you connect, it looks pretty much like a SQL Server instance, right? We have all our databases here. We do have some databases that are not system databases, but are created for us by default. These are what store the configuration and metadata for the big data cluster. So we don't touch those. We can create new databases though. And again, we're connected to the master instance right now. But the other thing I want to point out very briefly is this Hdfs node, this folder here at the bottom. This is the built-in Hdfs storage pool that I showed you. And I have some folders in here containing some CSV data. I have some airlines data and some flight delays data we're going to work with throughout our demos. But this is where things differ from a normal SQL Server instance, is now you have this Hdfs built in as well. And if we wanted to, we can right click on our big data cluster, we can hit manage. It'll bring up the management page that you would see in Azure Data Studio for any other database. But we have this tab here now for SQL Server Big Data Cluster, which will return some information to us about the big data cluster. Again, there's a lot of different moving parts to a big data cluster, and there's a lot of places you can connect to it at. So here's a list of all your service endpoints. Right now we're connected to the SQL Server master instance, but there's a Spark gateway. You can access your Spark stuff. You can access Hdfs directly. There's applications, there's management, there's logging areas and dashboards. There's Grafana dashboards you can connect to that have your log. There's a whole bunch of services that get spun up as part of creating this big data cluster. And you can see in one place here a list of everywhere to connect to for your big data cluster. There's also a particularly helpful button here called Cluster Dashboard, which will actually bring up initially what we just saw, but it has all the details for all the pieces of the big data cluster. So here's the SQL Server master instance, the container it's running in. Here's the compute nodes, data, storage, etc. You can see all these different parts and access and manage them through here, or at least see what they're doing built into Azure Data Studio. So that's kind of helpful. So to get started with a demo here, we're going to load some data. I have this data here, this file, the CSV file sitting here in Hdfs, airlines.csv. And if I right click on it, we can actually preview it and it'll just pull back it. Hang on, pull it back. Let me refresh this real quick. Let's see if it will actually display it for me. It should. No command. Okay, we're getting an error here. Hang on. I'm going to refresh my BDC connection. This was all working earlier, so of course it's going to crap out on me during the demo process. Okay, it is not going to go ahead and preview it, but if I were to normally, when you right click and you hit preview, it will just open up a text editor and show you the contents of the file, right? So this is a CSV file containing some data about different airlines. It has the name, the ATA codes, their call sign, what country they're from, whether they're active or not. We'll see the data when we actually go through and look at it very briefly in a moment. So first off, we're going to create our actual database to store it in. This is just another database on the master instance. I'm calling it airlines data. Now that I've done that, I'd like to actually access this data as an external table. So I need to create a storage pool or create an external data source called the storage pool. So that's going to point the master instance towards our Hdfs data so we can actually connect to it. And I'm going to create a file format for CSV files as well. So this is so Polybase can actually read this CSV file, and it knows that it's comma delimited and we need a comma to delimit the fields, and the strings are enclosed in quotes, and the first row is metadata, so we start with row number 2. So we've created this file format and this data source. Now we're going to create the external table, and this is the typical create external table syntax. So if you've used Polybase before, you've probably seen this. So we're going to create this external table, and we're going to point it to our airline's CSV file that's sitting in Hdfs. So now we have an external table. Now we should be able to just query the first 100 rows in the airlines table. And we get an error. Okay, and if you've worked with Polybase before, you've probably seen something like this. It's saying there's a bulk load data conversion error. Here, I'll zoom in for row 4, column number 7. Essentially, these errors happen in Polybase, and basically it means the data in the file is not what was initially expected. This is where the big data cluster's Spark capabilities can come in handy, because Spark can read a lot of things with not perfect formats, right? So I'm going to go to a different tab here. This is a second window I have here now, and this is a Spark notebook. So, or a Python notebook rather. I'm going to connect this to my big data cluster, and we're just going to read in the file real quick. Oh, kernel is dead. Great. Okay, hang on. I am having all kinds of trouble today. Let's try reloading this file one more time. One moment. Okay, here we are. Let's see if this kernel fires up or not. Give it a minute. There we go. We're going to connect to the big data cluster. Okay, hopefully we're back on track now. So this has to fire up the Spark application. This happens anytime you create a new window. It just needs to start the program. This is going to take about 30 seconds, but this is code in Spark that is just going to read this CSV file and show us the first 10 lines of it. So we'll give this a moment to fire itself up, and then it should be able to return, and we can move on with our demo here. There we go, it's getting started, almost done. There we go. So here's our first 10 rows of this file. And as I said, we have an airline ID, a numeric field. We have the name of the airline. We have an alias for it, various codes for the airline, their call sign, what country they're from, and whether or not they're currently an active airline. So this is just the first 10 rows. We're working on what's called the data frame here in Spark. We can actually print out the schema of the data frame, and we can see that we have airline ID as an integer. The rest are all string files, or all string data types rather. And the error that we got was actually for the country column, right? So country is a string, that's fine. I'm going to start Pandas so I can create a Pandas data frame. This is what I tend to work with. Pandas is another way of looking at data in Spark if you haven't seen this already. So in Pandas, everything is an object, but what I'm going to do is I'm going to just very quickly scan through this file and find out what is the maximum length of each column. So I've returned this now, and we can see here that our country column has a maximum length of 37, right? So it's a string of length 37. If I were to go back to our external table definition, we see we actually screwed up and we said the country maximum length is 10. So that's where our problem is here. If I make it larger, make it 50, now it should actually go ahead and run for us. So I'm going to drop this external table. I'm going to redefine it and say that the country column now has a length of 50. And now if I run this, I should actually get the data back. There we go. So this was just to show you that especially lengths around data type, issues around data types can come up fairly commonly in Polybase. And when you create a table in Polybase, it's not checking the data to make sure that the data conforms to it. It's just saying, okay, I'm going to create a table with this definition, and doesn't actually figure it out later that there could be a problem until runtime. So here we go. Here's the top 100 rows in our airlines table now. We have all kinds of current and historical airlines listed here. Now, as I said, this is an external table, so we can't do everything with it. If we were trying to create an index on this table, we're going to get an error back that indexes are not supported for external tables. I also can't update the data. If I were to try to change anything in this table, I'll get an error that DML operations are not supported for those external tables either. So this is really just a read scenario. But I can query this external data, which is sitting in a CSV file in an Hdfs store, just like a database, right? I can write a select query, I can filter. So here I'm selecting airlines that are active from Belgium, and this is what we have listed in here. So we're able to query this pretty simply, right? Just using regular SQL once we've established the external table, and that all works well. So that's our first demo here, just working with the airlines data. Pardon me while I close out of these now, and we'll go to the next demonstration we're going to work here with, where we do a little bit more with it. So I have another data set in addition to the airlines data set that we just worked with. I have a separate file called flight delays, and I can try to preview this one too, but I'm guessing it's also not going to work. Nope, not going to preview for me today, so that's fine. This has flight delay data for a couple years worth of flights, basically by it's got an airline, when it happened, what the delay was, etc. We'll look at the data shortly. So we're going to go back and we're going to connect to our airlines data database. There we go. And we're going to create an external table for flight delays here. Now, we've already declared from our past demonstration, we declared the storage pool and the file format. Those are the same, but we're going to create a second table called flight delays, csv.flight delays, because we're reading that data from a CSV. And we're going to define it as looking at that table. And the data type should all be correct this time, so we shouldn't run into any errors. We should be able to just select the top 100 rows from our flight delay CSV file. And here we have it. So we have year, day, month, departure time, arrival time, actual arrival time, what the carrier was, what flight number, what aircraft it was. We have so it's a whole bunch of different delay information we're just going to work with as something for a fun data set. So right now this is in a CSV file, which is great. CSV is an excellent big data format, right? It's nice and text simple. Everything can read a CSV file, hopefully. But it's not always the most performant. So there's another format, and if you've worked with big data, you've heard of Parquet, I'm sure. Parquet is another file format. It is a compressed format, and it's actually compressed on a per column basis. So it's kind of like a file equivalent of a column store table, if you're familiar with SQL Server. But there's a little more to it than that. So what we're going to do is we're going to actually take this CSV file and convert it into Parquet files. And we're going to do this with another notebook I have here, which just has some Spark in it or some Python. So we're going to connect to this. Hopefully it works for me this time. Kernel is dead. Okay, great. Hang on. Let me reload this file too while we're at it, because why not have a whole bunch of issues today? Okay, and why did it go up there? Because I dragged it into the wrong place. Here we go. Okay, so we're going to let this fire up the kernel again. There we go. We're going to connect to the big data cluster. All right, so again, I'm just going to load the first 10 rows of the data, which is going to take a moment because it has to start the Spark application again, which it would have had to do anyway, right? Once per tab. But then what we're going to do is we're actually going to take this data frame, which contains the entire file here. We're creating this data frame df equals read from this file essentially, and we're going to write Parquet, and we're going to write it to a folder. We're going to write a folder called flight delays / Parquet. So if we look here in our HDFS folder, you'll see we have flight delays and we have CSV. And as soon as I click start on this, we're going to start writing that out into Parquet as well. So the way this works is this is actually a parallelized process. Okay, here we go. Here's our data. Great. I'm going to go ahead and start that Parquet process right now, because that's going to take about a minute. This is a parallelized process, which is good. We happen to have 2 worker nodes in this particular cluster that I set up. So we're actually going to see 2 files. We're going to see 3 files. There's going to be 2 Parquet files each of which contains half of the contents of this table that has been compressed into the Parquet format, and there's going to be a third file that it writes out there saying it completed. And if you have a pipeline set up, you can have other processes that look for this done file as their signal that, okay, these files are complete, I can read from them now. Did this finish already? I told it to start. Did it not start? Refresh. Here we go. All right, so we now have our Parquet files, and as again I said, there's two files. They're actually named with a GUID, and there's a success file there that says, hey, these files have been written. So now we have the same data in both CSV and Parquet that we could access. So to access the Parquet version, we're also going to create an external table to do this. We're going to create another schema. We're going to create a Parquet schema now. We have a CSV schema for our CSV data. We're going to create a Parquet schema for our Parquet data. And now we have to define the Parquet file format for our external table, which is simple. We're creating a file format and we're saying with format type equals Parquet. So here we go, we have created the Parquet format. Now we are going to go ahead and create the external table. And this time I'm calling it, and I'll zoom in here, Parquet.flightDelays, right? So we'll have CSV.flightDelays looking at the CSV data, and we'll have Parquet.flightDelays looking at the Parquet data. And you'll notice the location down here is not a single file, it's the whole directory, because again, with massively parallel processing systems, you tend to not have your data in a single file. It tends to be across multiple files. So what you actually do is just point it at the entire directory. So that's what it's doing here. It's going to look at all the files in that Parquet directory, of which there are 3. It's going to ignore the success file, and it's going to read the Parquet files. So we're creating our external table here, and we're going to do our select top 100 from the Parquet data now. And there we go. So we have 2 external tables now. If we were to look in the airlines data database, we have csv.airlines, csv.flightDelays, and parquet.flightDelays. So we have 2 flight delay versions. But we're not done yet. We're actually going to create a third one as well. We're going to take this flight delay data again now, and we're going to write it into the SQL data pool as well, right? So the data pool is this array of SQL servers. I happen to have 2 in my big data cluster. So this data pool contains 2 nodes. We're going to write the data across both of these nodes now into the data pool as well. So to do this, we're going to, once again, use the airlines data database, and we're going to create a SQL data pool source to do this. So create external source SQL data pool. There we go. So I've created this source. I'm going to create another schema now called the data pool schema. And then I'm going to create an external table in the data pool schema. And in this, we're going to have the same table definition we had before, but now we're saying with data source equals SQL data pool and with distribution equals round robin. So we're taking and we're creating this external table, pointing it at the SQL data pool, and we're using round robin distribution. So essentially it's going to write a row to one node, write another, next row will go to another node, etc. It actually does this in batches, which we'll see in just a moment. But data is going to be distributed across all the nodes in the pool. Again, my pool happens to have 2 nodes. So here we go. We are creating the external table now. It is created. And now I'm going to copy the data into the SQL data pool. So I'm just doing a very simple insert into data pool.flightDelays and then select star from the CSV version, right? So this is going to take a couple moments here while it just literally selects from the CSV data and copies it into the data pool. Take about 30 seconds, I believe. All right, there we go. It's copied it all. Took about 42 seconds. You'll notice here we copied 19.3 million rows from those CSV files, or from that CSV file, there was only one, into the data pool. So we've done that. And now if we were to count how many rows are in the data pool, well, I hope we get the same number, right? We do, 19.3 million. But what if we want to see how much was copied onto each node of the data pool? Well, we can do that too with a different query. So what we're going to do here is we're going to say execute, use airlines data, select count from data pool.flight delays, but this little extra part at the end here, excuse me, at data source SQL data pool, this is actually going to return results individually from each node in the pool. So if I run this query very quickly here, we'll get 2 result sets back, and you'll notice they each contain about half of the number of rows. Not perfect, not exact, but you'll notice one happens to end in 512, so it looks like they're probably doing this in batches of like 256 rows and then switching to the other node. But you can see there is data in both nodes now, about half. So that's how the data pool round robin distribution works. And now that we have the same flight delay data 3 different ways, let's just do a very, very quick and basic performance comparison. How long does it take us to select each of the entire data set from each source, right? So if we select count star from csv.flight delays, this is actually going to go read the CSV files through Polybase like we had done before. So we got 19 million rows we're going to be reading from a text file. It's going to take a little time. It took about 7.5 seconds there. But let's try the same thing with Parquet. Remember, the Parquet version is compressed, and there's metadata as well. So this should be significantly faster. Look at that. We counted the same number of rows, but instead of 7.5 seconds, it took a little less than half of a second now to do this. And what if we did it with the data pool? So now we have the data divided up into 2 different SQL servers that can each return from. That's even faster. Look at that. That's instead of 0.4 seconds, that's a little less than 0.3 seconds, so even faster. So this is where we say the data pool is a great option to have data staged if you need very, very fast querying across a pool of servers. You can do that with the data pool. But that's not all, right? We can do even more. I've just been showing you basics so far, and that's about the extent of the demos we're going to see. But we can also join, right? There's no reason we can't join between all these data sets, even if they're coming from different sources or different servers, whatever. You can seamlessly join between them. So I have a query here where I'm going to just select the top 20 rows, and we're going to select from our flight delay data in the Parquet format, but we're going to join it to the airline data, which was in the CSV format. So coming from 2 different file formats, but these could just as easily come from 2 separate servers or systems. They're all external tables. You can all join them together. So there we go. We got our 20 records back of joined data. And from looking at this result set and the simplicity involved in writing the query, you would never know that this wasn't something that was all on one system to begin with, but it's really coming from very, very different sources. Okay, finally, I have one more little demo I'd like to show. Another thing that a big data cluster can do, in addition to accessing this data from external systems through Polybase and using Hdfs, you can also mount other Hdfs stores to it. So I'm going to try doing this very quickly. I have some data. I have a data set of parking tickets from the city of Chicago, and it's actually stored in an Azure data lake. So we can actually mount that, and I'm going to try to do it here for you. So if we right click on Hdfs, we have an option to mount Hdfs. You can mount other storage systems into this Hdfs and access it this way. So I'm going to create a path here. I'm just going to call it mount/parking tickets, and I'm going to the URI to get to my parking ticket data, and I have some credentials here I'm going to paste very quickly. All right, and we're going to see, will this work? So we're connecting to my data set sitting in Azure Data Lake and mounting it, and it looked like it worked. So if I refresh, now I have mount and I have parking tickets, and I have CSV file, and I have it broken up by month, but I have year 2003. Here's all my parking tickets in the city of Chicago. I'll try to preview them again, and it's probably not going to work. But this is, so you can mount, you don't just have to use data that's limited to your local HDFS store in a big data cluster. You can very easily mount other sources as well into it. So this is, coming from Azure Data Lake as well. So that is that. That is actually all the demos I had today. So we got through this a little quicker than I anticipated. Let's go back to the slides here very, very quickly. We can talk through what I have left. So resources. There's a whole bunch of great resources out there on SQL Server Big Data Clusters. Microsoft actually has a whole workshop you can access on GitHub through this link. If you want to learn more about Kubernetes, Klaus and Anthony Nocentino have some great material. Mohammed Darab has a wonderful blog with all kinds of Kubernetes information on it. Ben Weissman has a whole Pluralsight course on building a big data cluster. If you'd like to see a session on nothing more than how to build a big data cluster, he's got that there. And additionally, if you go to my site, this last link here, and I'll bring up the last slide so you can see it where I have it highlighted here. This will take you to my GitHub page where you can download this slide deck, all of the demos you just saw, get access to the data sets of the demos, and I have links to all those resources as well. So that's all I have for today. If we have any questions, I'd be more than happy to try to answer them. Otherwise, I think we're about done.